Hello, we're going to talk about solving systems of equations again. However, this time we're going to solve them using linear combinations, also called the elimination method. So not substitution and not graphing. So just another method for different types of questions. As you can see here in this system, 2x minus 4y equals 13 and 4x minus 5y equals 8. There are no coefficients of the variables that are 1. The coefficient of 1 problems we use substitution. This elimination, the linear combination method, will be most efficient when none of the variables has a coefficient of 1. What we want to do is we want to get these coefficients. We want coefficients with the same number but opposite signs. So we want a positive and a negative. So if we look, I have 2x minus 4y equals 13, and I have 4x minus 5y equals 8. If I look here, I see that this 4x is a multiple of 2x. So we'll do this by multiplying the top equation, everything, by negative 2. When I multiply everything by negative 2, we get negative 2 times 2 is negative 4x. Negative 2 times negative 4y is positive 8y. And negative 2 times 13 is negative 26. So what we have here, now if we look here at the coefficient of x, we have a positive 4 and a negative 4. Now what we do is we just simply combined these like terms. 4x and negative 4x is 0. Negative 5 and positive 8y is plus 3y. 8 and negative 26 is negative 18. So what we were able to do is we were able to eliminate the x and just combine the two equations. Once we get here, we divide both sides by 3. I get y equals negative 6. Y equals negative 6. Almost done. Again, we need an ordered pair. So we will take this negative 6 on y, and we'll substitute it back in to one of our original equations. I'm going to use the second one. 4x minus 5 times negative 6 equals 8. I have 4x plus 30 equals 8. And now I subtract 30 from both sides. Going to work backwards here. I get 4x equals negative 22. And from here we divide both sides by 4. I get x equals negative 11 over 2. So our solution is negative 11 over 2, comma, negative 6. This is the elimination method. We'll take a look at the example here on the left now. 2x minus 6y equals 19, and negative 3x plus 2y equals 10. If we take a look, this negative 6 is a multiple of 2, so I can multiply this second equation by 3. And again, 3 times 2 will give me positive 6. I need them to be the same number but different coefficients. So I'd have a negative 6 and a positive 6, which is what we're going for. So I will have negative 9x plus 6y equals 30. And then I'm just going to bring down the other one right below it. 2x minus 6y equals 19. Now we can combine these just by combining our like terms. Negative 9 and positive 2 is negative 7x Positive 6y and negative 6y cancel those out. 30 plus 19 gives us 49. So when I divide both sides by negative 7, I get x equals negative 7. From here again, we need to get our y coordinate, so we'll substitute. I'm going to use the top. I'll have 2 times negative 7 minus 6y equals 19. I got negative 14 minus 6y equals 19. I now add 14 to both sides. I get negative 6y equals 19, equals 33. From here, we'll divide 33 by negative 6. This ends up becoming negative 11 over 2. So our ordered pair solution here is negative 7, negative 11 over 2. Final answer for that particular problem. Now, as we look at the second problem on this one, if we look at 7x and negative 5x and 12 and 8, I can't just multiply one of the equations here. It's not going to work out to where we have the same number but a different sign. So what we'll have to do in these cases is multiply both equations to get a similar coefficient. What I'm going to do in this one particular problem is I'm going to multiply the top equation by 5, and I'm going to multiply the bottom equation by 7. That'll give me 35 out front here. So I'm going to have 35x minus 12y minus 60y equals negative, what is that? Negative 110. And then the bottom one here will give us negative 35x plus 56y equals 7 times, this will be 98. Now we can combine. 35 and negative 35 gets rid of the one variable, which is one of our goals. So we have negative 4y equals negative 12. Divide both sides by negative 4. I get y equals positive 3. In this particular problem, it doesn't matter which one we substitute back in. I'm going to do that up top here. I'm going to go ahead with the first one, 7x minus 12 times 3 equals negative 22. 7x minus 36 equals negative 22. Add 36 to both sides. I get 7x equals positive 14. I'll divide both sides by 7. I get x equals 2. My final answer is 2, 3. We were able to eliminate one of the variables and solve for the other. Our basic steps there. Those are the only two examples we're going to do. So here's our summary. We multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. That means they're the same number but different coefficients. We then will add the revised equations together from step 1. When we combine the like terms, we'll eliminate one of those variables. So we'll have an equation in one variable. Once we do that, we substitute that value back into the original equation and get our other value for our ordered pair. That is how we'll solve the systems. That'll be it for this. We'll practice a bunch of these here Monday, Tuesday, and possibly even Wednesday of the week. I hope you enjoyed your weekend. We'll see you on Monday.